We were talking about comparing two groups. We used this data set for them, The Biggest Loser, and we wanted to compare Jillian Michaels against everyone else. And so we had to create this column of Jillian versus everyone else. But now with Anova, we can actually do this differently. So instead of doing Jillian versus everyone, we can just do a comparison of the different coaches. So I'm going to insert pivot table. I'm going to come down to coach, trainer. So these are our different trainers. And I'm going to use how much they lost as my value. Make my first one a count. My second one's going to be the average. My third one's going to be variance. So let's compare all of these people together. Do it in a big way. So I need to come up with my grand mean. And that's a weighted average. So we take the count. So this is equal to count times the average all the way down. Oh, silly pivot tables. I'm going to copy this as values. So count times our average all the way down. This is the sum of these values. All right, so that is the sum, but I need to divide that by my total to get my grand mean. So grand mean is equal to this divided by this. I put D. It's not D, it's C. There we go. So the grand mean of 16 pounds. Awesome. Now let's calculate the distance of each of these from the grand mean. So this is Anna's distance minus the grand mean. Just going to lock this in place with the dollar sign. Come down all the way. So this is the difference each one of them has from the grand mean. And now I'm going to do the distance squared from the grand mean. So that's just their distance value, caret 2. And what that does is get rid of our negative values. Awesome. And now I can use that to go into my SST, which is the count times the squared value. All of these. And so my total sum of this is here. All right. It's my, so I'll just put this here. SST equals this number. Now for my SSE, that is equal to my count minus 1, that's very important, times the variance. All the way down, bring this over. So SSE is equal to this. Fantastic. All right. So to go from my SST and SSE to my total sum to my mean, so I want my mean sum treatment is equal to my total sum of treatment divided by G minus 1. That means I'll take this number divided by the count 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 1 and my mean squared error is equal to this number divided by my big N minus my groupings, and there are 8 groups. Perfect. That means my F ratio is this divided by this. Okay, so there we go. 2.4. Now let's find my critical value. That's F dist. No, that's F end interval. Probability is 0.05. Degrees of freedom 1 is G minus 1, so that's 7. Degrees of freedom 2 is this, minus 8. Okay, so in this case, our critical value is lower than our F ratio. So we would conclude there is evidence that not all of them are the same. Even though it's not a very high score, it's close enough. So that was using a pivot table to go through and calculate each of the different steps. No magic, just takes some time to go through. Let's just do the same thing using Excel stat. Click on Excel stat, modeling data, Anova. My quantitative variable is delta, and my qualitative variable is trainer. I've got a label. Just going to copy this and let's go back to our pivot table here. So we can see that the sum of squares, they call it model, but that's the same here. We got the same value. Sum of squares for the error is here. We got the same value. And our F is the same.